This video is on the objective understand and interpret critical values. This is number 1. So first video on a question related to this objective from your Newton-Alta homework that I'm going over. And in other objectives, I have gone over what a critical value is. Right? A critical value is just a boundary for the rejection region in a hypothesis test. So I'll go through the question that they gave us here, and I'll show you how we find these critical values, or how to interpret them at least. We're not asked to find them yet, just to understand and interpret them. Alright, so Ken, a market researcher, believes fees to use e-commerce content management systems are decreasing. Right, so he believes these fees are decreasing. He would like to test the claim that the average fee to use an e-commerce content management system is under $5. Using the computed test statistic of negative 1.77. So remember, a test statistic is something that's calculated from a sample. Right? So this researcher, Ken, took a sample of however many people, took the average of that sample, the average fee to use it, that they paid for these e-commerce content management systems, and then took that average and found its z-score or t-score, depending on what distribution you're looking at, a normal or a student's t, and then that came out to be negative 1.77. And the critical value is negative 1.96. Now, again, the critical value is just the z-score or the t-score that has, that is the boundary, the entrance to the rejection region. Right, the region with an area of alpha, right, an area of the significance level. So is there enough evidence for the market researcher to reject the null hypothesis? Now, before I go into this graph, I'm going to write down some of this information and start doing what I would be doing if I was doing a hypothesis test from the beginning. All right, so we have a claim. Now, first off, this is about averages. This is about some mu, right? Some population mean. So I'm going to say mu is the average fee, the mean fee to use these e-commerce content management systems. Now, this Ken guy, this market researcher, makes the claim. He claims that the average fee to use one of these systems is under $5, so mu is less than $5. That's his claim. Now notice that this does not involve equality. So when I go to set up the two hypotheses, right, the null hypothesis and the alternative hypothesis, the claim will be represented by the alternative hypothesis, right, because the claim does not involve equality. So the alternative hypothesis will be that mu is less than 5, and then this is the opposite of the null hypothesis. So mu is greater than or equal to 5, but we're going to be assuming here, when we actually go and perform the test, we're going to just be assuming the equal part, that mu equals 5. Okay, and so in this book and in Newton-Alta, they're just going to write down what you're assuming, the equal part in the null hypothesis. So you have a null hypothesis that mu equals 5, and the alternative hypothesis that mu is less than 5. Now, hopefully you recall from other videos, and I have other videos on previous objectives, where you have to identify whether or not you're working with a right tail, doing a right tailed, left tailed, or two-tailed test. that all depends on how the alternative hypothesis looks, right? This is the parameter is less than some specified value. So we're doing a left-tailed test. Okay, so that means when I look at the distribution of the, because I'd be looking at distributions of x bars here. I'd be looking at distributions of means, and then changing it to its like standard normal or standard t. So I'll just get rid of this and say this is either z or t here. We take the distribution of means, and because we're doing mean costs of these systems using these e-commerce management systems, and that can be transformed to either a standard t or a standard normal or a student's t distribution, which has a symmetrical bell shape to it. All right. Now, when we're talking critical value, remember every test is going to have a significance level. Every test is going to have a significance level, called alpha. When we're doing this critical value approach, and it's a left-tailed test, my critical value, which they gave us, they said the critical value was 1.96. Sorry, negative. They said it was negative 1.96. This is the value on the number line with an area of alpha to the left, right? Because again, this is a left-tailed test. Area equals alpha. And this area to the left of the critical value is called the rejection region. Because if my test statistic is in here, I'm going to reject the null hypothesis and lean more towards supporting the alternative hypothesis. All right. Now, they gave us this critical value, negative 1.96. From here, we would take a sample, and then from that sample, calculate a test statistic. Now, again, a test statistic is either a z-score or a t-score or something else, but again, this first couple chapters, chapters 9 and 10 that we're going to be working with, it's going to be either a z-score or a t-score, because we're so far only used to working with normal distributions and students' t distributions with so many degrees of freedom. And they told us that this test statistic was negative 1.77. He took his sample and calculated this test statistic for that sample's mean, and it came up negative 1.77. Now let's see where that falls on the number line. That would be here. Right, if negative 1.96 is there, negative 1.77 would be to the right of negative 1.96 on the number line. And notice that that does not fall in the rejection region. So what we'd eventually say at the end here was that we would fail to reject the null hypothesis. All right, because you're either going to reject or fail to reject both of these. So that means we're keeping this. You don't reject that, meaning you're not accepting the alternative. We lean more toward the fact that yes, based on this sample information, based on this test statistic for my sample, this is a good conclusion to make. That the mean fee, the average fee, is equal to $5, not less than 5, right? But equal. Okay, so back on the website, back on the problem, they're having you move some stuff, right? Now we said it was a left-tailed test, right? So move the first dot here to this first guy where there's area to the left only, left tail. Then I need to move the black dot to the z-score, to the critical value, right? The boundary for this rejection region. And they said it was negative 1.96, this critical value, this special z-score here. The entrance to the rejection region was at negative 1.96. Again, this is pretty sensitive. Right, let's see. Come on. There we go. All right. Oh, no, it moved. Okay. No. There we go. Oh, it moved again. All right. Be sensitive. Be gentle. Oh my gosh. All right, I'm going to pause this and come back when I get it. Okay, it took me an extra few seconds, but I managed to get the black dot at negative 1.96 like they asked, right? Again, these critical values, one more time, are the entrances to these rejection regions. All right, then the test statistic is where you're moving the red dot, all right, to negative 1.77. All right, so again, I'm going to try my best to do this on the first shot here. Negative 1.77. And there. Great. First try. All right. And again, you're seeing the test statistic for our sample is not falling in this rejection region. So we would fail to reject the null hypothesis. So the question is, though, they're saying, using this test statistic and critical value, is there enough evidence for the researcher to reject the null hypothesis? And we just said no. No, there isn't. No, there is not enough evidence to reject the null hypothesis because the critical value, no, it does not. The critical value is the entrance to the rejection region. It's all about the test statistic. No, there is not sufficient evidence for the market researcher to reject the null hypothesis because the test statistic does not fall in the rejection region. It's this fourth statement is why we're not rejecting the null hypothesis. And they did the same thing I did where I set up the null hypothesis, alternative hypothesis, talk about left-tailed tests, all that. Good. Let's see if there's any more to this. Nope, that's it for that question. So again, hopefully this video helps when you're doing that kind of a question on that objective on your own. And thank you very much for watching.